Yep, so we are good. Yeah. Thank you for being here in the session of machine learning for security professionals, building and hacking machine learning deployments. Uh, First of all, thank you for being in this workshop. This is going to be 160 minutes, a little less than 3 hours of workshop, where we'll build machine learning applications in the first half, and we'll try to find out some of the vulnerabilities in the next half. So our agenda is probably going to look like we are going to have some basic introduction. Although this talk or this workshop does not require you to have advanced mathematical knowledge, but to set the base of how do we find vulnerabilities in any applications, let it be software application or machine learning applications, you need to have some fair understanding of how the software code is written or how a machine learning application has been deployed, so that you can pen test it in a better way. So in the intro part, we are going to cover that, and in the next half, we are going to cover machine learning for security, where we'll talk about some of the applications in security field where machine learning has been deployed. Let it be advanced firewalls or intrusion detection systems or any other applications that use data to block malicious URLs, or to block malicious bots and all those kind of things. And in the last half, we'll try to secure the machine learning deployments, because recently, with the advent of Chat GPT and other LLM frameworks, there has been a new threat landscape, which basically is quite new, and we are going to talk about at the next half. And in the end, if time permits, we'll have an MLCTF where we'll try to hack and a detection system. Probably things will get more clear as we progress in the workshop. This is an hands-off workshop. If Okay, so I am Sagar Bure. I am traveling all the way from India to deliver this workshop. I've been to Black Hat DEF CON before, and I lead a project in OWASP, which is about securing machine learning deployments, which is also known by the name of ML Top 10, which is probably used by some of the organizations when they were drafting their AI privacy bill, namely US and European Union, when they were drafting their AI privacy bill back in February of this year. Okay, so this is how many of you have written or developed any machine learning applications before this workshop? Any of you? Okay, that's great, because this workshop is probably basic. So I'll try to keep things more basic, and we'll use some memes to understand all those things. So people, when I talk, they basically tell me that, hey, what is difference between artificial machine learning and deep learning? So we'll also try to understand these terms with the real life use cases, what is around us. So artificial intelligence is probably providing human-like intelligence to any systems. Machine learning and deep learning are more sophisticated terms. Machine learning is probably writing algorithms to provide machines to act to act or make decisions like human. On the contrary, deep learning is more sophisticated, where it targets few areas of machine learning, or a specialized area of machine learning, where you only target about the neural networks and probably the mathematics that our machine learning are built upon. Uh, so this is couple of use cases where ML or DL. It's all an acronym of machine learning and deep learning. It's used for pattern matching, pattern search, classification, regression, clustering, and forecasting. Forecasting in the sense that, hey, what will be the weather tomorrow? AI is used to forecast weather and stock market prices based on how the stock markets are behaving in the past month, and what are the company financial quarter results were like. Based on that, if you go to Google and try to predict or try to see a stock of any company, it will tell you where the stock will be the next day, on the next opening day. That's where Google AI deploys AI. Pattern matching is when you have cameras that can, on a traffic light, that can detect number plates to see who is breaking the traffic rules or traffic signals probably. So that's where all this ML and DL are used for. And there are a couple of ways to do it, in the sense that you have visual systems like cameras that has a different set of data. On the other side, LLMs or forecasting are probably textual based data. So that's where NLP comes into picture, which is natural language programming. Okay, so when not to use ML. So machine learning is not meant to be used everywhere. If it sounds fancy, because it requires high computation power, a specialized graphics card, and other sorts of resources. Let's say if you are trying to segregate or an employee based on the department. Whether he works for an organization where he works for an HR department or a product development group. It's kind of a clustering problem where you are trying to cluster different segments of group, but machine learning should not be used on that one, because it uh, uh, has some resources. You might be hearing about Chat GPT causing problems in green revolutions because it consumes power, because it takes a lot of computation power, electricity, to train it for a year. So that's where electricity consumption, also the heat that the server generates, also should be taken into consideration, not just how much the graphics card costs us. So that's another part of the challenge where you should use or should not use ML. So there are some of the applications in security, just like I talked in the first slide, WAF, IPS, IDS, malware detection. We are going to do couple of exercises based on the first half, which is machine learning for security. Antiviruses, all the antiviruses these days fight battles with the new sophisticated attacks. That's where machine learning is probably one step ahead of the signature based or the rule based engine. And it tries to predict a signature which has not even been discovered, and flagging them as a malicious login activity or as a malicious malware. Spam filters, probably in your Outlook or in your mail classifiers, it classifies those mails as spam or not spam, so that the users are probably safe from clicking any link on this on and that phishing emails. So this is the link to the workshop. If you have not, I mean, if you have not downloaded the VM and brought up the setup, I think this is the good time to do it, since there will be some sort of theories for the first 10 or 20 minutes. The link to that is this one. It's hosted on my GitHub. The another thing that's important about that website is it has lab guide, probably, which you guys don't have. It talks about all the lab exercises that we are going to do today, and this is going to be hands-on. If I'm not clear or not, or if you guys are not able to understand, apologies for that, and you can stop me wherever you want for questions. There is a Slido link also at the end. If since this is a long workshop and we can forget all the questions that you have. You can ask your questions on the link down here. Probably if you scroll, you'll see the Slido link over here. And stop me wherever you feel that you're not understanding that particular exercise. I mean, with that, we'll move to the next slide. Okay, so where were we? Yeah. So this is that link to that GitHub repo. So there are a couple of libraries that we are going to talk about. Don't get scared. Okay, it's back. So there are a couple of libraries which people get afraid of, which is OpenCV, TensorFlow, Keras. Um, uh, so all these are all the libraries that are used to build a machine learning application. To build a machine learning application, the purpose of it is. Uh-huh. Ah, okay. 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 Are we good? Okay. Yeah. So these are the libraries. The purpose of this libraries is this is highly optimized to do mathematical computations. Let's say you have a matrix of everyone understand what's a matrix, right? Okay, so if it's a matrix of 1,000 by 1,000, if you do a multiplication of it, you remember, right? In our high schools, you have to take a transpose and then do multiplication and add and all sorts of things. The purpose of all this is just to highly optimize the matrix multiplications, because since, let's say, if this is an image of 1,000 by 1,000, each image has 3 pixels, an RGB channel. It will be highly slow if you just do one matrix multiplication, and in ML you have to do a lot of matrix multiplication or matrix calculations, multiply and then add and then do you convolutions of all those things. The purpose of all this library, in short, is to give you a wrapper function where you can just supply it those matrices, and it will give you the multiplication of that or the addition of that or whatever you want to do in a very highly optimized way. Uh, Same with Keras and TensorFlow. If you'll ask me which one to start with as a beginner, I would suggest Keras, since it's all pre-built and you just have to supply it your matrices and it will give you the outputs. These are some of the tools on top of which you have to write your Python code or any machine learning code in any language. Conda, Spider. The purpose of all these tools is you don't need to manually install and take a burden of installing and creating a setup. Colab is web-based one, by Google, where you can just do pip install of any libraries that you want. Same with Jupyter Notebooks. The purpose of all these tools are to have an environment where you can play with the setup of installations and everything. Conda is a popular package in my opinion. Since it's environment management system, it allows user to create multiple isolated with specific libraries and dependencies. Let's say if you are working on multiple projects on multiple, let's say a vision based project of a license detection and a language based system, you can segregate all those libraries in different environments. So that's the purpose of all these tools. So MLOps, it's like if you must have heard of DevOps, right? Like so then came the word DevSecOps. Similarly, there is a word for machine learning operations, which talks about how do you do CI/CD, and there is an interesting part in MLOps, which is CT, which is called as continuous training. Well, this is just a high level overview to make you guys understand what can be the attack surfaces in a deployed machine learning deployments, right? Let's talk about a target or a victim over here trying to open chatgpt.com, right? There is a trained model hosting on OpenAI servers, which has a model in the backend. Let it be GPT-4, GPT Mini, or whatever, and it has a data set connected to it on the backend where they kind of train the model. Now you can access the ChatGPT in two ways, whether via their web application or by using their APIs. So as an attacker, let's say you ask something to ChatGPT and then you get a thumbs up and a thumbs down button, right? That's where, let's suppose if you do kind of a DDoS to the thumbs down button, and that's where you mess with their feedback loop. It will try to retrain itself on a bad feedback. That's kind of a one attack surface. The other attack surface could be the data set, where if you are training on a model which is a poison data set. I've seen a lot of attack surfaces where machine learning engineers, what they do is they just web scrap a lot of websites to as their base data set, and if one of their website is hacked or showing some garbage data, your data set is already poisoned. So and we have all been talking about data being the oil from last 10 years, and it has came to a point where you need to have a sophisticated data, and you need to pre-process it very well, so that your model that comes out of the training, it's pretty niche, and you expect the model to do what it is supposed to do. So these are the some of the terminologies which I'll be using in this talk. Data set, features and labels. Features and labels are probably in your facial expressions, right? You have eyes, you have nose, mouth. Those are the feature set that determines that, hey, this is a face versus not face. Target set and a training set. This will come more when we start coding. Uh, 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 and probability is, everyone understand what probability is. Model loss function, optimization, overfitting and underfitting. We'll understand this with the graphs in the next slides. So this is one of the basic terminologies, again coming back from our math class, which is called as mean squared error. So assume that you have a graph where you have a lot of sample points, or those are blue ones, and you are trying to make trying to make a line, which is your prediction line. So machine learning will actually just give you y is equals to mx plus c for those dots, where m being the slope, and you'll try to predict y, a future y, based on the input x. So let's suppose these are all x is dates and y is the price of stock, and then stock price is rising for some reason. So at a given x plus 100, you're trying to predict what's the y. So basically, as simple as that, that's machine learning. You're trying to fit a line between all these points. So a crucial factor to determine that your machine learning is good or bad is mean squared errors, which is basically the sum of the y, the actual y, which are your blue dots, and minus the perpendicular or the parallel line drawn from y-axis, which is y dash, and the squaring of it, and the sum of all and the summation of all that, division or divide by the number of points that you have on the graph. So that's basically mean squared error. You actually try to minimize the mean squared error to some extent, that your line actually fits all those points closely. Even perfectly fitting is a bad uh, machine learning output. We'll try to understand that in the next slide. So these are the three examples where I had three blue points, or three graphs with blue points, and I'll try to fit a line predicted by a model which is shown in blue, and which is a true function line shown with orange. Now, on the left side, you have underfitting. Underfitting is something where your line does not cover all the points in the graph. On the rightmost side, it's called overfitting. Overfitting is probably when your line fit all the blue points. So what's bad for both of them is that the first one, for obvious reason, it does not cover your blue points. So any blue points that is on the graph is probably going to get missed by that blue line. So what you're trying to do here is you're trying to make a blue line so that my next blue dot fits on it with a higher probability. On the right side, although it fits all the blue dots, but there is a very less chance that a new sample, if there is a new blue sample, it will likely fit on the blue line, which is a model line. Whereas if you see the mean squared error for both of them, the mean squared error for the left one is quite high, whereas the mean squared error for the right one is quite low. So that basically make us understand that mean square error neither should be too high or too less. It should be somewhere in between so that it covers some of the dots. Okay, so basic terminologies. There are three forms of machine learning: supervised, unsupervised, and semi-supervised. And let's try to understand that with an example. How many of you have been to IKEA or understand what IKEA is? Okay, that's great. So IKEA is a store where you go and order your home decor things. So let's assume that there are three guys sitting and bought something from IKEA. So supervised learning is something that he knows what to do. He bought a chair and a table. He has a manual to assemble it, and he knows how to assemble that, right? That's supervised learning. You have the manual, you have the product. Unsupervised learning is something, let's assume that you lost that manual. Somehow you have to figure out that how many legs are there of that tabletop, where it goes in by a trial and error, via fixing it itself. Reinforcement learning is he lost the manual. He doesn't know everything, whether it's a table or a chair. So he has to do some trial and error method to find out if it's a chair or a table or a bed or a cupboard or anything. So those are the three use cases. Uh, in machine learning terminology, supervised learning is you have labeled data set. If you are trying to segregate data between cat and a dog, you have images which are labeled saying that these are cat images and these are dog images. That's supervised learning. Let's say you have images in a folder with just named as one.jpg, two.jpg, and all images are like that till thousand.jpg. So these are all unsupervised learning. He has to find certain features on the facial face of cat and a dog to find which one is what, and cluster both of them separately. The last one, reinforcement learning, is something different. I mean, we are going to talk about that in the upcoming slides. Okay. A lot of people say me that, hey, I don't know maths. I understand that problem. Even I had the same problem where I didn't wanted to have the understanding of math, but it slowly comes with the time. And in the era of Chat GPT and generative AI, I quite actually feel that no one needs to have that level of mathematics and understanding and linear algebra to build machine learning application. And we are going to do that in the class without even having to write a single line of code, uh, using some low code tools to build our first machine learning applications. This is linear regression. So linear regression is the most fundamental machine learning algorithm used for modeling relationship between y and x-axis. So let's say here it's 10. Since we talked about the prices of stock was $5, $10, $25 on day 0, day 2, day 4, and something like that. Now let's suppose if there is a day 11 or a day 15, you want to predict that what will be the stock price on the day 15. You have to find out the equation of the line between y is equals to mx plus c. You put on that x basically, which is your day 15, and you will get a result of y. So this is what machine learning linear regression is. You try to find out y, uh, the value of y-axis based on your x, and uh, what this training step is. Your training step is finding m and c by a mean squared error methods. You know some x and y's. Those are your training datas, and you will try to fit this graph so that you can find an unknown y for an unknown for a known x. Okay, so this is the first demo we are going to do with linear regression. If you go to the lab guide. It will walk you through all the details that it has. Just give me a second. Why does it show like that? Okay. Yeah. So this, I hope everyone has access to the OVA file and have spun up this Ubuntu VM. This is the directory structure where in the desktop we have a folder called lab. In the first half, as we talked, we'll talk about ML for sec. In the next half, we'll do sec for ML, which is all the code sample for security for ML. Um, and it has all the details about the lab. The CTF mentioned at the end, we are not going to do that one. I have a new CTF which is not mentioned over here, but I'm going to demonstrate how the problem statement is towards the end. So this is a pretty simple logistic regression, sorry, linear regression demo, where you have X and Y. That's your training sample, and you're trying to find a line, equation of a line is finding an unknown MNC. MNC basically it's for to find out any another Y for a X in a future amount of time. Any questions till now? Am I making sense a bit? Okay. Okay. The password for this is ML. Where am I? Okay, so there are a couple of Python codes written over here. The first one is create dataset, where it will create the random x and y coordinates, and then in training a model, we are going to load that dataset which was randomly created, and train a model to find out the values of m and c. Now, if we see create.py, it's basically a simple Python code. Uh, any of us does not understand what NumPy or matplotlib is? It's okay to raise hand if you don't. Okay. So NumPy is again a specialized library for matrix multiplication, transpose, and doing all sorts of matrix calculations. So if you see, it's just a function which calculates np.random, which creates random numbers and creates a matrix of x and y sample points. Okay, probably I'll open this in Sublime so that it. Okay, so this is the train model function, and all the Python code in a machine learning looks similar. When I say similar, there are steps to build a machine learning algorithm. So you load a data set, you pre-process a data set, and then you train a model, and then you test a model, and then you print out an accuracy. Maybe sounds confusing, but when you will see this code in all the labs, you will understand or make sense that machine learning is just 5 steps, where you load a data set which was created in create dataset.py or a Python function. You basically split the data set into 80:20 ratio. 80:20 is my number. You can have a different number or a ratio. So basically, training and testing is something like you train a model on a particular data set, let's say 80% of the data set, and then when you have a model, you test the model on the rest 20% so that you know what is the accuracy of that model, or what is the mean squared error for the model that is trained on the next step. So that's the next line is building a training model. That's where the beauty of Python comes in. You already have any of us know what sklearn library is? Okay, yeah. Can you turn on your mic and let us know what sklearn is? Or have you heard about? How did you heard about it?
Let me see. Oh, yeah, it works. Okay, yeah. So for sklearn, it's we use it a lot in our work where we want to manipulate data to push into some form of machine learning model. So sklearn has a lot of templates inside, right? It allows you to split your data into test training sets, and then if you really want, you can also import the models that have already been pre-coded for you as well.
Right.
Just makes the ML development or ML ops a bit more convenient.
Like is the same line. If you see line number 4, train test split, that's basically a function coming out of sklearn, and that's where I've used it in line number 14. And you also have everything pre-cooked on the line number 17, which is a linear regression model. You just have to call dot fit on the object that was created using linear regression function. And the dot fit will basically and give him and supply him the data set uh, so that it fits the model, and you have the object ready on line number 18, where you just have to call predict with your testing data set. Now you have to just give him your x test because you are going to have a y prediction. Remember in the slide of mean squared error, we had a y and a y dash. So y prediction over here is y underscore pred is y, and y test is the actual y dash. You have to subtract all of that to get a mean squared error. Now, if you see, you must be wondering that, hey, how do I? Those are two matrices, right? Like a single dimension matrix of the number of y values. How do I, subtract it, square it, and divide it by the number of points? Obviously you can do it with mathematics and doing multiplication right there in this Python code, but you also have a function mean squared error that also which also comes from sklearn metrics library. You just have to give him ypred and ytest. It will just give you mean squared error. So that's where I was talking about the libraries in the libraries slide, where you have all the function optimized function, where you just have to supply him the ingredients, and it will give you the food that you want ready to eat, just like what I'm with the mean squared error we have. Um, so we are going to run this one. Okay, so I've created a data set which is a random sample of blue points, which can be your stock prices and at day on the y-axis. If I'll close this, it will save my data set in the /tmp folder. Now what I'll have to do is just train the model. And if you see a nice blue line, or sorry, a red line, which is your model. Now, if you want to predict anything on a day 15, you just have to extrapolate it, and then you'll get a value on y. This is just a basic understanding of what an ML is just fitting that those red lines in a blue dots graph, as simple as that. But it will not, life is not easy. It will not be as simple as that. You will have a lot of scattered data all over the place. You will have to you find a line in degree of x where x is to the power 2 or to the power 3 or something else. But this is just to understand what is a basic ML algorithm looks like. I'm going to close that one and move to my next slide. Okay. Any questions on the previous slide of linear regression? I hope not, because the next one is this is the low code machine learning tool we have I've seen or came across long back. There are a lot of other, but if you go to this link, you will find out that okay, you will find a lot of alternatives of it, but okay, so this talks about teachable machine. You can go to get started. There are a lot of other projects where you have an audio project where it will detect that, hey, this is a human voice or a computer voice. Pose project where it will just body pose or mark over this. We are going to do an image project, and the good thing about it, you can embed it in your mobile phone or in your website, or in your Mac or Windows operating systems as well. So these are all the classes. You have to classify. Let's say if it's Sagar versus Sagar with phone. So what I'm going to do is I'm just going to create a class Sagar, and then maybe phone I'll use. Okay. Maybe you can also try this alongside. It just requires your webcam access. Okay, I think it'll take me a bit, so I'll just move this screen here. Okay, now if you see, I've just recorded couple of images with just myself and myself with phone. And if you press trade model, it will do training. I mean, the data set is quite small over here with just 50 use case, 50 data points. Now, if you see, I think stuff doing it like this. Okay, maybe this is how it is. So without a single line of code, we built our first machine learning algorithm. And the good thing which I like of this place is you have three ways where you can deploy it. TensorFlow Lite being deploying it on an embedded devices. TensorFlow being you can deploy it on your Mac OS or Windows OS. TensorFlow JS is, let's say, if you have a website where you want to integrate this kind of thing, you can just copy paste the below JavaScript code in the HTML or React or whatever backend code for the website you have, and it will start working and it will start showing you the screen as it shows in the demo over here. Okay. Can we try this demo here now? Anyone wants to give it a try on my laptop? Okay. Okay. So this completes our lab one. We go to lab two in couple of after a couple of theory again. I understand theories are boring, but we'll have to live with it for some time. So this is our classification problem. Classification is something where you try to classify cat versus dog, food versus not food, um, uh, and all other things like food versus not food, what you should eat and what you should not eat. Since as humans we have been trained uh, over the years that what we should eat and what you should not eat, right? Uh, Similarly, it's like that. So, I mean, let's again understand this with a use case. Let's suppose you are blindfolded and you try to taste different beverages and try to make understanding that, hey, is it a coffee, a cold drink, or is it or is it a croissant? So based on your life experience, that's where the data set is. You try to predict that, hey, this is a coffee or a cappuccino or any other drinks. That's where the classification is. You try to classify red dot versus blue dot, or based on the features, if it's a human versus if it's a dog. I mean, dogs have different facial expressions, hair on the face, more hair on the face, and humans have, he can be wearing specs, he can be wearing earrings and all those things. It can, based on those features, you try to classify, as a class A and class B, just like we did in the last demo for. Last demo for mobile versus just Sagar. So that's where all the classification is. I think you all, this is a basic web application firewall high level diagram. You have a client, you have a web firewall which try to uh, block the incoming HTTP request based on the parameters. If it is an SQL injection, if it's a script tag added on a URI parameter, so that it can stop those harmful requests for, let's suppose, for SQLi trying to steal login credentials to the backend server. So that's basically high level understanding of what a web WAF is. In the first half, we are going to build a WAF. How do you build a web application firewall using machine learning or a classification problem? And in the next half, we are trying to again hack a web application firewall using a mutation operators. We'll understand what mutation operators are. So this is a data set. If you look on the left side, it's all good queries, in the sense that it can have queries to final warning page. It can load some CSS files. It can load some JavaScript files on the left side of your screen. On the right side of your screen, you have certain features. Since I talked about human face features, there are features in bad queries which has script tag, directory traversal, and something like uname, etc. PD, like a system command. So those are all bad queries. You have, this is just few snippets of those queries. I've taken it from an open source GitHub project. You can have, to build a sophisticated web application firewall, you need to have a data set of millions of samples, so that you can build a robust firewall. And we are going to use regression model to build a web application firewall for good queries and bad queries. Okay, so before going to the Python code for the web application firewall, we'll try to understand what a TF and IDF is, term frequency and inverse document frequency. So it's basically again maths. So I'll just go through the definitions, uh, and and we'll go to the code, or the next lab exercise in the next slide. So term frequency is, let's say you have a document or a piece of a paper. To find the term frequency, you just have to divide the frequency of that particular term and the total number of words that the document has. Inverse document function, or IDF, is is this formula basically, where you just have n, like a capital N is like the total number of documents in the set of documents folder you have, and CI is the number of documents which contains the word I. Let's say if it's about calculating word hitcon, how many documents does that, number of documents does that have the word hitcon. So similarly, these are again some of the parameters that are used to determine uh, uh, words that appears a lot across the document, and term frequency summarizes how often you often given a word appears within a document. So in the next slide, it's like WAF using logistic regression. Okay, so we are going to go back. So this is all the data set. If you see the bad queries and good queries and try to do good queries, it has all good redirections to product pages, to pages like scenario and other redirections. But in the same place, if you see bad queries, it has all bad URLs where it has script tags, PHP injection code, LFI, directory traversals. So it's just the machine learning algorithm will just try to make sense of all this data set, and it will try to make a model so that uh, for the next incoming query, which is not a part of this data set, it will try to flag it as good query or bad query. Uh, uh, so that's where the usefulness of machine learning is. Anything apart from this can also be detected beforehand if it's a bad query or a malicious query. Okay, now if we go back to our Sublime. Okay, so there are two Python important Python files in this one. Uh, it's train.py and predict.py. Now, if you see the train.py, it's where we'll do all the magic of loading a file and loading a good query and a bad query file. So this Python code for machine learning also looks the same, where you import a library in the first half, and then you load the files or you load a data set. You split a data set for training and testing, and then you have a vectorizer where that's where a TF-IDF I was talking about. It calculates the term frequency. It split the data set. And gives you a bad count and a valid count, or a good fit on a bad fit. Now this is a logistic regression model where you try to make circle or a line between your red dots and a blue dots in the previous slide, so that any incoming dot it can correctly classify it as a valid request or an invalid request. And then you have so the last half is evaluation, is basically you use your X test to calculate some of the matrices. So there are a couple of matrices in machine learning calling as accuracy and F1 score. Let's not go too deep into that because it's highly mathematical to understand all that. But accuracy is something like, hey, everyone says that, hey, I have a 99% accuracy, I have a 98% accuracy. So what does it mean is it's just that it's on a 100 prediction, 99% times or a 99 predictions will be true, and all of that one can be or might be false. So that's where the accuracy is, and then you have a good sample and a bad sample. So you basically used to train this, and then you calculate the accuracy and matrix so that you can report it, hey, my model is performing this good on that bad. So as a disclaimer, all these things are just to make you understand how the demos are, not to use in production with any case. Okay, with that, so since this is a VM, it will take some time, uh, uh, but for production use cases, there are sophisticated servers where you have graphics card, which takes not much of time. Okay, with that, before that, let's go to the lab exercise. So this is the lab 2, where you will basically train the model. It will give you the scores. Uh, the accuracy scores, and in the next one you try to predict whether it's an SQL injection good query or an SQL injection attack with union select keywords. uh, let's see if it gets streamed. Yep. So after I run the train.py function, what it does, it loads the good query text file and the bad query text file, and it also counts how many good samples were there, how many bad samples were there. Now if you see this data set is kind of skewed towards good samples because I was unable to get more bad samples. Probably if you have a firewall running on a real production environment, you can log those using Splunk, and then you can have more bad samples. But unfortunately, I was not. So my data set is skewed towards good samples, which is intentionally to make you guys understand that you should have equal number of good samples and bad samples to make a model more accurate. Now what I'll try to do is I'll just try to run predict.py function, and it's asking for a query. Let's suppose if a user queries slash product web page to get a list of products, right? It's obviously a good query, and he should see the product items that are being listed. Now let's suppose if he tries to uh, do an SQLi. It says that it's a bad query, right? So that's where machine learning comes, and trust me, this data set is not part of or this sample which I just timed is not part of the data set which I have trained it on. So what machine learning does is it tries to predict a new query, whether it will be a good query or a bad query, based on the logistical regression model. There can be other models also, which I have commented, I think, in this code one. Okay. Okay, probably it's some other one. But yeah, so now let's suppose that, hey, you must be wondering that, hey, I've written a code. How do I share it with some other engineer who is not a machine learning engineer? So there are a couple of ways, like an H5 file, a PB file, or a pickleized vector. Vector is just a serialized or to convert to safe binary machine learning models. So you can just share this pickled vector. You just have to do a model.save. And you can share this pickle vector in, and the other guy who is probably an operations guy who just have to load that pickles vector and just start making good queries versus bad query classification. Okay, any questions in this lab or in this demo? Anything? Am I going slow, fast? All good? Okay. So yep. So this is what a metrics of you guys don't need to understand it, but the reason of the purpose I'm telling you all this is, in future if you hear these words, you can at least get involved in, hey, I've heard this word, maybe in HitCon's workshop. So precision is like true positive, so TP is true positive, FP is false positive, and these are a couple of formulas. You don't need to remember, you can just Google it up whenever you want to. So precision is how many true positives versus the total number of predictions. There can be chances that, let's say if it's a cat and a dog problem again, you give him an image and you know that it's a cat, and the machine learning model predicts that it's a cat, it's a true positive. False positive is something it's predicted as dogs. So that's where the precision is. Recall is what proportion of actual positives were identified, F1 score is this formula: 2 into uh, precision into recall upon precision plus recall. Uh, so precision is basically a metrics that measure the accuracy of positive predictions based by a classification model. Um, Precision actually answers out of how many positive the predictions, how many of it were correct. But anyway, we don't need to understand it. So we'll go to the next demo, which is malware classifier. What it will do is it will try to classify an exe file or a binary file, where if it's a malware or not, just like two class problem, a classification problem. The next demo which we had 138,000 samples of the malwares. And there were 56 feature sets which were extracted from the PE file using the PE file command line tool. Okay, before going there, let's try to understand the lab 3 data set first. So we have this data set. If you see, this is an exe file, and let's try to focus on the one which is at the end, which is uh, memtest.exe, which has its MD5 hash and separated by those vertical lines, and it has its header characteristics and what are the offset and the size of the strings. Is it a legitimate or a not legitimate? So if you see at the end, here it's written over here, if you see, it's written legitimate, and corresponding to that it's 1, right? So it means that it's a legitimate exe file. There are some other binaries in that data set. If you go to the lab exercise, it will tell you if it was legitimate or not legitimate. So based on this information, what subsystem was, what its checksum was, what was its operating system it was running on, and other features, we'll try to train a model which will predict any new incoming exe or any binary file, to predict if it's a legitimate or a not legitimate binary. Okay. Okay, so if you see data.csv, this is your data of all the malwares. There are a couple of samples which has legitimate equal to 0, which are all malware files. And these are all the headings which talks about what like the characteristics of malware. This is a legitimate malware which is setup.exe, and other examples. So as I talked, there were this particular CSV file has 138,000, closely to that, binary files evaluated and fed in here. Now the classify.py function is the next step of train.py function. Okay. This is again a classify.py function, and everything looks similar. You load a data set, you divide a data set, you detect what know what machine learning algorithm you have to use, and sometimes it's hit and trial for everyone, in the sense that you might be wondering that, hey, I can solve this using linear regression, but it might be solved using logistic regression. That's where the accuracy or the matrices comes into picture, that hey, which one should I use? Which should I use? Decision tree classifier? Should I use logistic regression or a linear regression? You'll have to find out that using the precision, accuracy, and recall matrix. The best for the best of 3 metrics is probably the best one you should go ahead with. And that's where I mean I'll not go in detail with all the Python code line by line which I have written since with the crunch of time. But I'll be happy to answer questions at the end. If you have a problem understanding any line of any particular lab exercise, if you face any problem on. So now if you see, you just have to, sorry, you just have to run this code, which will load the data set and it will call and it will give you all the metrics whatever you want to do. The purpose of this one is just to classify on a given data set and understand what are the matrices where you can say that hey, this is a good machine learning algorithm or not. Now if you see, there are the accuracy and recall for all this is 98%, 91%, and something like that. So the reason being the data set quite large of zero point 0.1 million. Uh, and that's where you classify a malware. Now, if you can take this example and use it in any antivirus solution that has the malware classification built-in function. Okay, we'll quickly uh, go back to the slides. We just went ahead and did the malware classification demo, where you try to classify a malware versus not malware. So this is all neural network. Now we are slightly going deep into the deep neural network parts. Machines are always categorized as human brains, and neural networks are like that. It has neurons where you feed your input layers, and then you have some hidden layers, an activation function, and it will try to give you an output whether it's hot or cold. Similarly, you get senses, right? When you touch a drink, your nerve system tells you that it's hot or cold, and then you take actions based on that. Neural network is similar to that. You have your input layer, you have your hidden layer. No problem. And then you have an output layer. Similarly, if it's important, you can take it. Okay, so you have hidden layer, input layer, hidden layer, and output layer. We'll talk about it when we go more into convolutional neural networks. How do you, convolve an image and then predict that hey, if this is a cat or a dog? Again, some sort of math which we don't want to understand, and rather we don't have any need of understanding it. But again, these are all activation function which will try to make your model more precise. Sigmoid, tanh, and ReLU used should be used wherever it's applicable, but not everywhere. And this is how we in the next demo, I think it's we are going to do a digit sign recognition where you write one to like digits from 1 to 9 and try and uh, train it on a convolutional neural network. So this is all how a training and a testing phase or a retraining phase of a convolutional neural network looks like. You have an input image. You basically try to pass those. Let's suppose if it's a image of 18 by 18, right, and 18 into 18 is, let's suppose it's 784. You have input layer with 784 neurons. That's where your all digits are. Uh, 3 can be written in RGB channel, but you have to convert it into grayscale, which is values from 0 to 255, and then you pass those value from 0 to 255 to make hey, this is 70% 3, 10% 4. Machine learning will never tell you that hey, this is 3 or this is 4. It will just tell you that hey, this is 3 with 70% accuracy, just like what our other solutions tell you. And then you have to set a threshold that hey, about 70% I'm going to declare that this is that particular number, let it be 3 or 4. Then this is how a training phase happens. Like you have all the digits on 0 and 1. You just pass the data on left side, and you then back propagate to uh, to to the nodes. Okay, so the circles are here called nodes, and the line which you see are called edges. Edges have some mathematical uh, functions going out there, which will do from one layer to other layer, and then it will propagate saying that you have 9 output or 10 output classes from 0 to 9, and basically you'll get to a point that the output on the fifth node will tell you 70%, saying that hey, 70% I am fifth or 5 digit. So learning is just like that. How many of you have played this game? Okay, so you just throw and then you try to make your error corrections so that you try to hit at the center. That's what the learning was on the previous slide. You have something like global maxima and minimal maxima. Like global maxima is the maximum of the graph. Local minima is local maxima or local minima is particularly for that of that curve. The reason of this is minimizing the error. You have to find a global minima of this graph to find a minimum value or to improve the accuracy of that functions. Okay. Um, we don't need to go through all this. Okay, so this is again a representation of a MATLAB simulation that I did for one of the project, where it tried to find the global maxima rather than finding a local minima. Uh, and there are terms like bias and weights, uh, which are okay. So which are basically uh, like Wi and alpha in the above graph, which will help you from moving from the left node to the right node in a convolutional neural or a convolutional deep neural network architecture. These are all activation functions. Like even in the slide we talked about sigmoid, which is SGD, RMS prop, and Adam, and it's an optimization to optimize those error so that you get to the global minima to minimize your error function. Okay, so this is how the summary of maths look like. Again, no need to understand or memorize this. Just give it a look. You have input layer where you have the values of the pixel values at x1 location, at x2 location, similarly till xn. And then you have weights. When you go from the input layer to hidden layer, you multiply the weight, and then you add a bias to it. In the blue, at the top in the blue you see over here. Now E1 is basically a summation of all that, and A2 is also similarly x1 times W11, which is weight 11, x2 times weight 12, on the blue, all the blue lines that you see here. And similarly, this one A2 equals to x1 times W12, x2 times W21, x2 times W22. So this is all mathematics that happens. The purpose, no one does this with pen and paper. You have inbuilt libraries to do all that. And then when you get to a point where your final equation becomes y equals to the previous layer before the output layer, there can be n number of hidden layers. So A1 multiplication with W11 and A2 with W12, and then you add a bias to it. So this is how a training of happens, and then you have a prediction where it just runs from left to right, saying that it can be 2 with this much amount of probability. Okay, now with that we'll try to make an spam classifier. Spam classifier also has certain words, like it will make you sound like an urgency to make you click somewhere or give you free vouchers. or free cache with links making you click somewhere so that you install some malware software on your end devices, or it might also have some typos. The hacker might have not used ChatGPT to craft that phishing mail, probably. So again, neural network from spam classifier, um, which is our last demo, I think, before we move on to the security for ML part, which is quite interesting when I give this training. Uh, so this is a spam classifier lab, where you again have a lot of data set, which is located inside nn underscore spam classifier, um, where a particular message is whether is spam or not spam. Uh, Now, if you go to the code of this particular CD, no. Okay, so this is one more level of exercise where you have where I have created objects called spam classifier, which has functions defined inside it where you want to classify or where you want to retrain or train the model. So so this is again a good coding practice. When you start writing good code on machine learning, you'll have to like make objects so that the code is more readable and production shootable. Now what it does, it's basically asking you for an input to type the message. It creates an object with spam classifier and it tries to call the classify function on that particular message, which is defined over here, which is like the input SMS. And what it does, since we are trying to write alphabets, right, in the chat box, it will try to try to compute it into numbers. So because every mathematical calculation is number at the end of the day, so you try to transform or vectorize those alphabets into numbers so that you can run prediction on that particular model file. Now here, if you see, he's asking me for a message or a mail that I have received. I'll just say that I am good. It says that it's not a spam message. Now similarly, if we try to run this uh, with a bad spam example, let's say free for gift, it says that hey, this message is a spam. So this is again an spam, building an spam classifier using machine learning, and all of this text messages which I have typed in are not part of the data set which I have trained it on, which again proves the point that machine learning can be a step ahead from the rule-based engine, where you can predict something which is not part of your data set, just like how humans read from, understand from past and then make future decisions. Any questions till now? Is it getting boring or anything you'd like to add? Okay, maybe the security for ML part will be more interesting, so that I'll just skip a couple of slides. This is how a convolutional network happens for two predicting 2 and 1. Like this is all convolution, these are all maths. How do you convolve a matrix to find an edge detection problem? Edge detection is similarly like how do you locate where are faces? You might have used apps like Facebook. How does it tag and how does it find where people are in the photos? That's how they convolve the image, and then they find out the edges of their faces, and then they locate where are the faces, and then on a step ahead, who is that person? So that's a two-level problem for that particular use case that we talked. So this is MNIST uh, classification problem, and here is a hint from for the CTF that we are going to do. Uh, although that CTF which I'm talking about is not a core ML CTF, it will require a lot of knowledge about like the application security, which we have already known of. So this is all a digit sign recognition with a lot of sample data set. And Devanagari script is used for various South Asian languages, including Hindi, Sanskrit, Nepali, and other ones. Digits are like a symbol. Digits are symbols used in scripts with 0 to 9. CNNs have demonstrated performance on classifying whether it's a 2, 3, or 4, or a 6. Like for postal card recognitions, you have postal cards or checks where you need to identify what is those numbers. That's where it's used the most. Uh, about the data set is a small 32 by 32 image uh, with columns containing from 125, 1025, and there are this many rows in that example. The columns are the multiplication of 32 by 32, which is like pixel values from range 0 to 255, since this is a grayscale image, and column is all the labels where it tells that it's a image of 1, 2, or 3. Okay. Okay, now if we go to okay, probably I'll just walk over it, and this is again straightforward, where you create a data set of 2 and try to predict from the samples that you have generated in line number 13, so that the prediction can be from label class in like defined in line number 7, which can be 2, 3, 5, and 7. I'll leave this one demo since we are running out of time for the last second session. Uh, okay, so this is phishing, a fraudulent attempt to obtain the personal information, multiple DMs or SMS or social network spear phishing and all the sorts of things. The problem with spear phishing is targeted. It understands the interest. With machine learning, you can have personalized interest, just like when you buy some shoes or scroll some shoes on Amazon or Line, you will start seeing ads on your applications or other messaging applications. That's where the targeted ads are there. So it's spear phishing. Uh, with machine learning, you can have done it in minimum time. You don't have to do a manual building a corpus of data in a last text format. uh, okay, we are going to skip this all dictionary attack. Okay, so traditional API security, since I have been talking about rule-based engines and machine learning-based method, in the past, the security solution were predominantly reactive. A new API attack signature sample would be found, analyzed and added to the malware list by the researchers of cybersecurity. Machine learning or AI algorithm play a key role in this shift, where they are not a one-stop solution for the cybersecurity concerns. They are rapidly useful in automating the complete patterns of preventing APIs against API threats. Adding ML to the API gateways, the case for adding ML as a security layer in API security. And since we talked about the WAF use case, where it prevented the new attack signature before it was discovered. So enterprises can automatically discover anomalous API activity and threat across API infrastructures that are traditional miss. Even in case the standard security measures cannot be useful. Okay, there are type of API security attacks, which are bot attack, injection, authentication, and other forms of API attack. And API security is crucial for two main reasons. The first one being APIs are often served as gateways to sensitive data, and I read somewhere that 80% of the HTTP traffic these days are API traffic across all web, and there are a couple of specific type of attack. I'll just talk about the first one, where machine learning can be used to detect and block bot activities by analyzing HTTP requests. Where, like, if you have a captcha, you just the bot directly goes to the captcha, whereas a human takes some certain path to reach to a captcha, and analyzing a user behavior and capturing those mouse movement. You can, with machine learning, you can say that, hey, this is a bot or a human, to prevent bot attack. You just have a page, Cloudflare page, when you log in, you just have to tick I am not a human. So based on that, you can, sophisticated web pages or firewalls have captchas, that those can also be bypassed for obvious reasons. But there are some ways where you can detect human versus not human, or human versus bot, using machine learning. um, okay, so this is a couple of slide. I keep an interval, although for questions in the first half we have, before we move on to the next one, which is like securing, and where we break some or find some vulnerabilities in the machine learning applications. Okay, any questions? Anyone wants to take a break for water or something? Are you guys good? Okay. So this is couple of interesting new research. Machine learning has been there, and the algebra has been there for past 20 years. But machine learning were already inside academics, and it was not making too much into the productions. Since with ChatGPT, there are a lot of commercialization on machine learning application, and every company is running behind machine learning to infuse machine learning in their production environment. So this is how a machine learning in production looks like. Any of you have seen how a DevOps pipeline looks like, or in a diagram? Okay, so this is similar to that, but what the difference, you have a developer writing code, you have a versioning control, and then you integrate it into a pipeline. You use Jenkins to build the code for a software, and then you ship those software to using the continuous delivery. Now here the only difference, or the only major difference, is you have a feedback loop, which is again a form of attack vector. But you take feedbacks from user, that how the model is behaving, and then you retrain the model at particular amount of time. Just like, let's say, what ChatGPT does, right? Like, you gives him a thumbs up or a thumbs down button based on the feedbacks that he has received over the day or over a week. ChatGPT tries to retrain it and make its model more accurate. um, Earlier, there used to be a translate service. Let's say if you want to translate English to Chinese or Hindi or French, right? Uh, Google Translate used to give users freedom to correct its translate service. Let's say if I type "How are you," it might in French it might sound something, but I can type the translation of something else, and it will try to retrain the translate service on that particular phrase that I have given. ChatGPT already now know these problems. That's why they already have a thumbs up and a thumbs down button. They don't want to open everything to the user, so that they start messing with it. There you have here in this diagram, you have couple of steps or buckets from data validation, data pre-processing, training, evaluation, and validation. Some of the steps you already know. Data validation is something you have a data source. Data validation process is something new, which takes care that hey, is this data safe or not, to be went inside for the data pre-processing and the model training steps. So that's where the data validation box comes into picture, and the rest of the other model evaluation and model valuation is the same steps which we talked about earlier, where you validate the model using F1 score and the accuracy on all those parameters. Okay, so this is a possible attack surface on a machine learning deployments. Uh, Number one can be poisoned data set. The other one thing can be skewed models. Wherever the model takes input from users, the model can be skewed, and then you can have adversarial attacks. Which we are going to demo probably in the next slide. You can steal the model from sitting from the outside, which can be a black box attack, and some sort of other network and framework exploits. Okay, so this is how a AI security assessment should look like. Just like I mean, I've formulated this with how a security assessment for any software or a web product looks like, web service looks like, but with a little difference, because since this can be accessed via APIs or API security obviously is a different talk altogether, but you can access models using APIs. There can be attacks on that, application attacks on the machine learning, where you can do security assessment or pen test using reconnaissance, threat modeling. We are going to talk about threat modeling probably at the end, before the CTF, and then you have model inversion and hybrid attacks, and the threat modeling. So this is how a security assessment can be formulated. This is just a proposal. I've formulated it on something of some research paper. Reconnaissance is something like you have a chat GPT service, and you try to see, hey, can you write a Python code where the Python code has os.system calls? Is it trying to run it on a server? And then can you ask chat GPT that hey, can you run the Python code so that when it runs that os.system command, you can do directory traversals to the etc password file. So that's where the reconnaissance comes into play, where you can run a Python code. Can you run a Python code on a LLM model? Obviously, ChatGPT does not do it, but there are some LLM models that can run Python code on the backend, where you can do cat of os.system /etc passwords. Okay, adversarial attack is your model actually learning what we expect it to learn, or your model is learning something what a hacker wants it to learn. So this is a next demo which we are going to do. So what it is, you have a stop sign, you add some perturbations, and then you have a mailbox, which will get predicted as a mailbox. So there are algorithms based on research papers where it generates perturbations in such a way that with bare eyes it will still look like a stop sign, but when you feed this model into the same machine learning model, it will predict this as mailbox or 120 kilometer per hour. So a good example to understand this is, let's assume that you are driving an autonomous vehicle, and instead of stopping at the stop sign, it speeds up to, let's say, 1 kilometer per hour or something like that, right? I've seen people wearing stop signs in their t-shirts and driving in front of the car, and the vehicle, autonomous vehicle, randomly stopped, since it was a t-shirt of stop sign. So autonomous vehicles are kind of still vulnerable to adversarial attacks. Okay, so we are going to do this demo, which is hosted over here. I'll suggest all of you opening this one. Okay. So this has certain models which is already pre-loaded. Everything runs on the client side using JavaScript model system. an ONX file based system where you can deploy models right onto the browser. We already talked about digit recognitions. We are going to demo straight sign recognition in this one. So I load the model. There are a couple of other images, like a stop sign, 20 kilometer, 120, another one. Now, if I run the neural network, it will try to predict this image as 120 kilometer per hour with certain probability, which is 99.85%. So machine learning will never tell you that, hey, this is stop sign. It will tell you that, hey, this is stop sign with 99.85% of prediction. Now, what we'll try to do is we'll try to turn this image into 120 kilometer per hour with some attack vectors. And these are all a name of papers by Carlini and Wenger. There are some other attack vectors, which is Jacobian based, where he just changes one pixel of the image. By changing that one pixel of the image, the neural network will incorrectly predict the model. The purpose of this paper or research is it places that pixel at the location such that it generates a very strong adversarial image. Now we'll try to use Carlini and Wenger, which I believed is the strongest, and we'll generate an adversarial image. It might take some time, but if you see, there are some noises and distortions added in the original image. Obviously, with the bare eyes, it from far it still looks like a stop sign, but what we do is if we run this image on the same neural network, it will try to predict this as 120 kilometer per hour with a very high probability of 99.90. So this is what an attack vector looks like. And I've seen people unlocking phone with the photos. That's called photo injection attack. Or there are ways of doing these things. So what I'm trying to say is machine learning, although it's good to make predictions faster, it should also make predictions accurately, because there are a lot of financial sectors. You have your mobile phones unlocked, and I think a lot of things are already compromised if an attacker can use your photo to unlock your mobile phone. If your phone has a camera based unlock system, I mean, you might be going to airport doing a face scan and walking inside the aircraft, or going in the security checks, right? This is one of the attack where where someone can impersonate someone and get the security clearance to bypass the security check. Okay, so this was the first demo for adversarial learning, where the image classifier, where let's say I call it man in the middle attack, where an attacker can intercept images going from your Tesla car to a centralized server, add perturbations to it, and the response that comes from the central server, which makes the predictions, can be 120 kilometer per hour or whatever the attacker wants to do. So adversarial attack is obviously an optimization problem, where you try to optimize the perturbations in such a way that when you add that perturbations to the input image, uh, it still looks like a stop sign, but given at the machine learning model, it will predict it's the same class. Any questions on the first demo? Okay. There are a couple of toolboxes that are already available to craft images that can fool any machine learning based systems. Let's say if you have a vision based systems, you can use this toolbox to generate adversarial images to fool any machine learning algorithms. Okay, we are going to talk about a couple of research papers. One pixel attack for fooling deep neural network, which was Jacobian based algorithm in the demo, which I was demonstrating earlier. If you see, these are all very low resolution images, but it just changes one pixel on here, and then here, and then here. It just changes one pixel and the machine learning model will try to predict this ship as a car with 99% of probability. Similarly, in the next one, which is horse getting predicted as frog with 99.9%. So it just changes one pixel at any location defined by the algorithm, and it will predict, it will basically misclassify the input image. Similarly, similarly for the deer getting predicted as airplane. Okay, so this is again demo for adversarial attacks. And adversarial attack is kind of fascinating and very easier to hack. But you don't even need sometimes this sophisticated algorithms. I mean, I've seen examples where you have apple uh, uh, written on top of mangoes, and it will try to, I mean, with a pen and a paper, you can get it misclassified as a different fruit altogether. Okay, so these are all examples and demos from the research papers. This is the human wearing a T-shirt with numbers written on it, and when he walks on the street, he is getting predicted as a car because he has number plates kind of things on his T-shirt and a design. Another example of getting misclassified is you have distorted inputs. Uh, Maybe the pre-processing part of the machine learning is not so well, so that it can bring the image back in proper shape. So if you have a distorted image, this guy on the right side can be predicted as someone else. So it without any fancy mathematics. So this is an example which I was talking about, where an apple written iPod on the top can be classified as a pod. So you don't need sophisticated mathematics to to make a misclassification. I think last day we were having dinner, and there were few breads which was shaped as mushrooms. When I tried to, uh, make a prediction of count my calories, I predicted as mushrooms, and added it as mushroom where it was not. So what I'm trying to say is, machine learnings are not robust, and not all machine learning algorithms require sophisticated mathematics for you guys to hack it. You just need to make fun of these algorithms, and it will start behaving like a black box. Okay, so this is how an adversarial black box on a black box model looks like. Black box model is something you are not aware of the parameters or what linear regression models or logistic regression models it has used. You're just sitting from outside, and you have an access to API, let's say for ChatGPT API, and you try to understand the output of ChatGPT based on the input that you provide. Just like any one of you know what prompt injection is. Prompt injection is such a way that you ask LLM models, and it tells you the uh, secrets that it has stores. Let's say if the LLM model on the server it has hosted, it has some API keys. Any user from outside, without even logging in, they can ask, hey, what is your API key? Hey, what is where are you hosted, at what location, what is your IP address, what is your web server IP address, what is your login credentials. So that is prompt injection. Prompt injection is trying to ask questions in a sequential fashion so that the model will start revealing its secrets. That's what prompt injection is. And with LLMs increasing its space, prompt injection has also increased its attack surfaces, and I see a lot of prompt injection attack in these days. So adversarial attacks, basically, this is a recap. Adversarial attack involves crafting input data intentionally to mislead the machine learning algorithms. And black box method are machine learning models where the internal workings or the parameters of the models are not known. You're just sitting outside. An attacker have a limited knowledge or no access to the target model. Uh, Okay, so these are all the cross technique transferability metrics of adversarial attack, which is probably defined as differentiability between the models I and J on the x-axis and y-axis, as the proportion of adversarial sample produced to be misclassified by model I that was correctly predicted by model J. Okay, so these are again some of the on a attack on the black box model with input as one having which was legitimate on the upper half, or an adversarial image with some dots or some perturbations added on the adversarial samples getting predicted as y. Okay, now we are going to demo the adversarial attack using code. The first one which we did was using web application. The next one is going to do via code. Now, if you see, okay, this is. So this is an elephant image. We are going to misclassify or make this classify as chameleon. Okay, these are all the data set with all the animals that I have in my data set. This is the predict function. Okay, so what I've done here is import all the libraries. There is a library called Inception v3, which is a pre-trained model for classifying images on what animal it is. Now, if we see and try to run this code, okay, so this folder has this many files. Now, if we run, now if you see, it's taking input as the first argument as the image path, and in the root directory I have elephant.jpg, which I will load it on the prediction function, and it will predict this. Okay, so I've run wrong code actually. Okay, now if you see, I ran the predict underscore inception dot python function, and it predicts that it's an elephant with 94% and tusker with 1%. So now what I'm going to do is I'm going to create an attack file um, over here. Okay, so this is an attack file. Now there are three things on this. You have the image path where you want to attack. You have this is just a placeholder where you need to have a tagged elephant.png and then a diff part. Diff part is the perturbations image that I was talking about in the stop sign image, and hacked elephant is the image where it will look like elephant, but we'll see what it is in the demo. Now this is all again a Python code where it loads the model, and then you basically load the image back. And then you do what Carlini and Wenger did in that web application demo. I have created the backend server in an Ubuntu machines to mimic the same thing, which was there on the client side using JavaScript. And you do copy function and gradient descent. This all actually comes from the Carlini and Wenger paper using the cost optimization, and then you basically save all those images on a TMP folder, which we are going to see. Now if I run attack inception.py, it will try to classify. I've given it the target class also, which it be a chameleon which looks like a spider or something. Uh, now the prediction probability class. If you see it, it will start going up. Now the prediction class probability is the target class. Let it be 120 kilometer per hour from stop sign to 120 kilometer per hour, which is like our target class. Now the final probability of the target class which we wanted to misclassify is 99%, which is fair enough, fair and good enough. Now if we try to run the same file, now before that we should go and see how the file actually looks like. Now if you see in the Python code, okay. Now if you see in the Python code, this was a hacked elephant photo. This still looks like elephant, right? And then you have a diff image. Diff is the image between your initial image elephant.jpg and hacked elephant.jpg. That's the perturbations that I have added in the elephant.jpg to create it hacked elephant.jpg. Now if I run this code, on the hacked elephant, let's see what it predicts. It should misclassify it to like the Indian elephant, which the photo was, to an African chameleon. Now if you see the probability for this one is close enough with the target class probability that we set in the first while we are creating an attack sample. So this actually is a sophisticated way if you want to try out with different image samples or on a different image based system to classify as from person A to person B, or classify Putin as someone else maybe. Okay, so this marks like the attack for the adversarial attack. Okay, mitigations to so people say that why how do we mitigate these problems, like how do we make sure that if there is any perturbations added to the input image, how do we get around with that? This is again still a research topic right now, but the recommendations are that when you train a model, include adversarial samples from include adversarial samples in your training data set, so that when your model trains, it understands which, if it's a training, if it's an adversarial sample or not adversarial sample, right? But you might ask that, hey, how many algorithms should I add? So there is no answer to that question, because there are a lot of samples, and this problem is existing from 2 years without getting solved till date, as far as I believe. There are adversarial attack on FaceNet. I mean, we are going to just talk about this. So this is how a Siamese neural network looks like. No need to understand all these mathematics or the diagram, but Siamese network on a whole, what it does a signature matching to verify a check if it's signed by you or not you. So in a database, there will already be a signature, and whenever you sign a new check, it will try to match if it's the same person signing that image or not. So Siamese neural network is used for that. This is architecture of FaceNet. Again, no need to understand this, but maybe in future in life, if you understand, if you get across the architecture, of anyone asks you about the machine learning architecture, it probably looks like this. You have layers, like we talked about input layer, hidden layer, and the output layer, and then you have number of parameters. You might be hearing about ChatGPT having 8 billion parameters or 9 billion parameters. So that's what on the right side is. Parameters are those omegas, W and X, which we saw in the previous slide, which is all the mathematical computation variables where you multiply your input size and the output size on. Okay, so that was that adversarial attack on the FaceNet architecture which we did. Model stealing attack. Uh, is there any? Okay, is there any? Okay, there is no image. Okay, so there are model stealing attack, and this is again a research topic if you're interested in Gen AI and LLM models. There are a lot of open source LLM models these days, and people are concerned about the fact that, hey, this is my open source model. Will anyone change just one or two parameter and try to claim my model is as their own? Uh, so that's where model stealing attacks are. Your devices, when you click a photo, it has an AI inbuilt feature on it. Uh, uh, People say that, can someone not reverse engineer that camera application and steal my AI photo enhancement model? That's a offline attack, because you don't need internet access to reverse engineer your AI photo enhancement machine learning algorithm that's running on your phone. Online attack is where you make an API call to a ML service provider to find out to do a black box cloud service attack. So offline model attacks are for in the applications like antivirus, IPS, IDS require work without internet connections, and models that are devices on the end devices, at the edge devices, make them available for predictions. Deployment may or may not be a solution at scale, so that's where the purpose of offline or deploying it on edge devices are. Model could be deployed once on the device and have certain push or patches or update, extracting it from firmware and other places. Okay, so this is how uh, this is about demo 9, uh, which uh, which I oftenly marked as do it offline, because since it's an offline model stealing attack. You have an application. If you go to uh, the lab exercises, it will talk about how do you execute that. Okay, so this is lab 8. Okay, so lab 9 on on the device, it will have offline model stealing attack as a folder, where it has an SDK app where you have a model file where you can run an attack, an offline model attack. Just like an application SDK, you have a lot of Java code. Um, an offline model stealing attack will have alongside a model file, which will be deployed with alongside that application of that Java code. Okay, online black box model stealing attack. These are some of the resources, like Vortex AI, Big ML, which gives ML as a service, where you have to, where you access the API, where you access the ML service as APIs, to make API call to to uh, to do the computation server side, do everything on the server side. You just get the result, just like what we did with teachable machine. You just provided him with the photos, and it predicted it as human versus not human. So those are all the web services, and if you want to hack those, you need to have upload a poisoned data set, or have a feedback loop where you can provide the feedback to the web services. So there are about a couple of ways, and we talked about in the reconnaissance part, where you can make sense of what it can be. Okay, so this is what MLS a service, a train model. You have a train model residing somewhere. Again, with a chat GPT example and a target class and an input class. You have a target class for, let's say, a spam classification image. Uh, you provide him with a spam message, and then that it says that, hey, this is a spam or a not spam. This is what a target class for ML as a service does. ML as a service is just hosting a trained model somewhere else, so that the service gets us what it wants. Okay, so this is an attack methodology uh, for model stealing attack. Uh, what model stealing attack is, you try to create a replica of the model that is hosted on a cloud server using using API calls with random text uh, to the cloud provider, which is F, and you try to create a replica called F dash using the API calls. One good way to restrict this is via using rate limiting. But a premium user with a premium subscription cannot be rate limited for obvious reasons, and that's where this is one of the attack methodology which I have found for some of the LLM service providers, which predicts, which creates a copy of a model. There are a lot of black market tools which can also do this to create a fake copy of the model of, let's say, ChatGPT or GPT-4 by doing some random API calls to the users. So this is like you collect the data and then you query APIs to generate label from target model, and then you use labels. Let's say if you give him message, hey, this is my message, classify it as spam or not spam to ChatGPT, and use the generated labels to collect data to train the duplicate model. Now what you're trying to do with this is you're mining data from ChatGPT, and you use that mined data to duplicate the model locally for your own benefit or your own use. That's where the model stealing is the attack methodology. I mean, you make queries, you try to predict the data which you don't have access to because the organization does not want the data to be open sourced, and you train the model on the data that you got from making API query response, and make and train your own model. Model skewing attack, we already talked about it in couple of times. This is a slide from the poisoned feedback loop where an attacker can skew the model by providing incorrect feedbacks, so that his uh, feedbacks are completely biased towards queuing the model at a particular direction. Whatever the user performs, the model is skewed towards the user wants. Okay, now we are going to do the last demo, which is skewing spam filters. Skewing spam filters, meaning that we are I'm going to play a video which has an attack vector for skewing the spam filters, um, and then probably if we can do it live as well. Okay, so this is how an ML ops data poisoning attack architecture looks like. I made this like 8 months back, where you have an attacker panel on the top left. Probably let me pause this. You have an attacker panel on the left side, on the top left, where an attacker can do a label flipping data poisoning attack. What is a label flipping data poisoning attack? Let's say we have a data set where every message is labeled as spam versus not spam. What an attacker will do is, he'll attacker with an access to the data set, he will just flip one label of a data set. Let's say there is a message calling free, click here with a tiny URL link. He will just flip that spam label to not spam, and the model will retrain on that poison data set and deploy it via this user panel, which is accessible to users via, let's say, some domain name.com, where user can put it message, and user can start user can basically send the message to the backend server, which is deployed via pipeline on a backend server. Uh, so this is how an architecture of a MLOps data poisoning attacks look like. You have a performance tuning and lot of other parameters or other boxes, and every box has different attack vector associated with it. Okay, let's go to the demos. Okay, on this screen, you have this web application where user come and tries to test this message where it's spam or not spam. This is the MLOps pipeline. I mean, you can go inside the VM and there will be some folder inside sec for ML with spam classifier. It's probably inside that. But this is a DevOps or a MLOps pipeline for hosting both the web services looks like. Now, if you see, I'm trying to predict what this message looks like, and it will say that hey, this is spam message probably because it has typos and everything. Now, if you see on the ML on the bottom right, bottom this one, you'll also have the message getting posted to the predict model uh, endpoint. I mean, it says spam versus ham. Ham is an synonym for not spam. Now, if you see the attacker panel, what it does, it says that hey, every 2 cup FIFA final, it marked this as not spam, and the model on the right side, on the bottom right side, whenever when I clicked that, it retrained itself on the poison data set. Now, when a user will actually go and type the same message. Okay. Now, when the user will go and type keywords like free, 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 click me, it will basically predict this as not spam or ham, which will say that hey, this is a safe message. Uh, so that's what a model skewing or a data poisoning attack looks like. This attack had two attack vectors in one. The model when it retrained, it skewed itself, and the attacker panel when he inserted a new data set, he had done a data poisoning attack in this one. So this is how a data poisoning an skewing attack looks like. Okay, so this was the architecture of the attack vector, which you saw. Okay, now before going to the CTF part, let's talk about generative AI and their security for a couple of seconds. Uh, since there are a lot of attack vectors that are quite fascinating uh, in the Gen AI world. So there are good things about generative AI, uh, where it can make our work faster. You don't have to scroll through 10 links on Google to find out your answer. You just have to provide like whatever query you used to give in Google search, and then basically uh, you uh, you get your answers on the fly. Now there are ways where chat GPTs are getting exploited, or any LLM model to be precise is getting exploited using some of the jailbreak techniques, which are of known as switch method, character play, and other model scaping methods. The one of the last one being prompt injection attack, which I talked about. Uh, and if time permits, I have one demo on on prompt injection attack as well, or a CTF. We can try it on prompt injection attack, which is quite interesting in a way that you don't need any sophisticated tools like burp and map or any Kali machine to start hacking chat gpt or start hacking anything. You just need to have to write sequence of queries so that the chat gpt start answering which it should not answer. Let's suppose that you ask ChatGPT what is the recipe for making bomb. It is not supposed to answer that, right? Because of ethics and all those things. So that's where the prompt injection is. You basically try to get answers from ChatGPT which it is supposed to not answer. So that's what the prompt injection attack is. Cyber defense automations, ChatGPT is used to generate rules, and for reporting tools, for threat intelligence, for secure code generation. Let's say you have a pull request on a GitHub or any source control, and you want to uh, write a write a pull request description for it. Generative AI is probably used there. So generative AI on the good side is used for process improvements and productivity of any engineer. It is also used for phishing, writing more sophisticated phishing emails. Generative AI is tend to write more sophisticated phishing email that bypasses spam filters. Uh, you know. More sophisticated than what human used to write. So this is what an ML top 10 project under OWASP does. It tries to list all the top 10 attack vectors on a machine learning deployments. I think we covered couple of them, from data poisoning attack to adversarial attack on the top right and the orange, and some of the model stealing attack as well via the reverse engineering of any attack sample. So this is what an ML top 10 project talks about, uh, which is also located at mltop10.info. And every attack vector has its attack scenario. How can you attack this projects and everything. Now, if we go, I mean, let's just go to see one of the example. So this is what an OSML top 10 project looks like. The first one being input manipulation attack. I think this was renamed from adversarial attack to input manipulation attack. Uh, I mean, there are a couple of lines in this which talks about how do you prevent it, uh, what are the risk factors, like a security assessment of every top 10 attack. Like what is the exploitability matrix of it? Is it easy? So yeah, it's quite easy to exploit this. What is the security weakness? What is the impact? So this is all the risk factor. Uh, uh, which categorizes all the the attack samples from its high severity level to low severity level. Any questions till now? Okay. Before the last section before we go to the CTF is threat modeling for any ML application. So again, this is again a high level understanding of how ML security assessment should be or could be, but it's not formalized. It's just based on my experience and my research work that I have done. I've created this guidelines to help any engineer understand how to do a security assessment of any machine learning deployment. So you first understand the application, whether it's a vision-based system like an autonomous car, where if it's an LLM-based engine like ChatGPT, so you get to understand the use case, like what the product capabilities are. Again, the next one is it attack surface identifications. So gather, which includes gathering of your test cases. Let it be, can I access this model via using APIs? Can I use it via web forms? Or what do I have access to the SDK? So that is all attack surface identification. When you open a web page, are there any feedback buttons? Are there any way where I can submit feedback to the model, that basically falls into the attack surface identification segment. And then when you create a threat modeling, you model the endpoints. Hey, what are the ways where I can interact? Are there any API keys that can be exposed for that LLM service or for any ML service? Uh, what are the endpoints that the users can communicate with the model? uh, Couple of them again, which talks about making a chart list of the ML top 10 list. Adversarial attack, high severity, low severity, something like that. Making an assessment matrix of uh, your ML deployment against the top 10 attack vector. Basically, securing if there are feedback loops, simulate the feedback loops abused by attackers. Maybe if you just do thumbs down, are the LLM model verifying that if it's a legitimate feedback or if it's a false feedback? Okay, with that. At the end, reporting and mitigation. So, whatever work we have done, just like we do it, the threat modeling assessment and software applications, the add-on being uh, uh, accessing it against the OS ML top 10 project, and reporting and mitigating our findings, and comprehensive mitigation proposals, and work with SMEs or the machine learning engineers based on the implementations to fix those. Okay, so this is a CTF for. Uh, I'm going to demonstrate it towards the end, but this is not a hardcore ML CTF. You'll need to use some of your application knowledge. Now, I will try to give you an illustration of what the CTF is all about. And this time we'll have to do it all together. Okay, now read this thing carefully because there is some keywords from the talk that will help you to make this thing similar. So what is this? This is highest ML capture the flag challenge. There are a couple of cars. I mean, I'll leave it to you guys to read this thing slowly and carefully. But on a high level, there are 5 cars, 3 to 5 cars, which are trying to bypass a surveillance system after robbing a bank. And then there is a police department with a camera. Camera installed on a traffic signal. You'll have to make this car bypass it so that it does not get blocked or get busted by the police cops. Uh, so it's like you are part of a heist, you know, and then you'll have to make as a cybersecurity professional or as a hacker, you'll have to make uh, your friends or your uh, other heist people to bypass the chair. It's hosted publicly, so you can access it. So here is the number to that car. Maybe try to find some end resources which are exposed. As a hint, there is some portal which is exposed where you can upload a model and train a model to bypass this system. Maybe try to find a hidden page somewhere where you can upload a model, where you can upload a bad model. We'll talk about how the bad model will be uploaded, but let's try to find out using our application security knowledge. How do you find out hidden page? Any questions in this one? Give it a 5-minute read uh, slowly because it has some typos which are intentionally put on that CTF. Just give it a read, small read. Probably that's towards the end, before the last slide, but uh, if you have any questions, feel free to ask. Okay, to move this, anything you got? Maybe try using directory enumeration in this website so that you can find a hidden page. Maybe use there is a hidden page which you have to bypass, where you can upload a model file so that it misclassified that red car, and the heist is successful. So you are like an hacker. You are towards uh, the black hat guys. When you are trying to bypass that page, if you have found, it's very simple. I mean, as a reconnaissance, you can click on Start Challenge and uh, read about what this city police department website looks like. There are contact buttons, vehicle fire. Okay. Okay. So probably to help you guys, if you do directory enumeration, you will find an admin page where anyone of you able to bypass. What's the password? Okay. Okay. Now we're able to find something after this. Okay. What's that? Line number 90 something. 96. I cannot see from here. So so basically that file, that page, you have to upload a zip file. You'll have to upload. So let's suppose that the beacon number plate was 4126 or 4122. You have to mislabel the last two to 9. So it should, you have to create a model uh, where it's a label fitting. Like from 2, you have to label it to 9, and then retrain it, make it a zip, upload it, and then it will start retraining on a poison loop. Okay. Now, did you go to okay, yeah, okay. Let me go back a bit. Okay, when you press start challenge, did you find something here? Maybe try to write a chat GPT code, to write a Python code to import MNIST based data sets, and how to do a mislabel Python file from 2 to 5. Maybe try doing ChatGPT or Perplexity everything. And you can use Google Colab if you have problem copying from ChatGPT to that machine. Uh, you just search Google Colab in Google search and it will give you Colab link. And just do ChatGPT copy paste code from there to here. And you can also type something like give me a code to save file as zip, uh, a new H5 file as zip. Okay, maybe if we go back to the login page. If you see there is a commit also here. The uploaded file is not .f5, so it should be .f5 and .zip. After you have retrained it, any one of you, you just have to press simulate and that car will be bypassed in that line. Okay. Anyone wants to try? Should I give the solution? Okay. Okay. We'll keep some time for the question so that I'll just. I think everyone reads till the source code. I just asked ChatGPT to give me a Python code. I mean, he used Keras, but I wanted TensorFlow. I asked ChatGPT. Here is a simplifies using TensorFlow to manipulate data set by swapping the labels from digit 2 to labels 9. The code snippet uh, is designed to run on a Google Colab environment. Okay, that's cool. That he is also saying where to run it. So I just copy pasted this code, ChatGPT code, to my Colab over here right now. Now, if you see, there is no file over here, and I just want to run this code. Okay, yeah, started running. Now it will automatically save an H5 file, and it should. Yeah, it did write an H5 file. I just need to download this. Where is the download button? Yeah, this is download. Okay, since it's a big file, it will take some time. So I just have to zip this, upload it on the web server, and the model will retrain it itself on a Poisson dataset. Uh, and when I press the simulate button after that, it will bypass the police department card. For any of you who wants to have a solution file, it's where this is how it will look like. It said bypassed earlier. When we upload an H5 zip file, I hope it will take some time since this is a big file. But yeah, so if you want the code, I can give it to you, or just chat GPT, as simple as that. Uh, when you press the simulate button, it will just get bypassed as it bypassed earlier. This is an image, so the solution file has this. Any questions on the CTF or anything? I think we have just 1 minute left for any questions or for any doubts. So which marks basically towards the end. Just give me a second. For the CTF, I hope you guys enjoyed the CTF. And this is the ways you can contact me via LinkedIn or reaching out to my website. And thank you. I think we are done. Yeah. There are a couple of good courses. I mean, it depends which areas your interest lies in, where you want to build machine learning application or you want to hack machine learning applications. I think so. That's where the first half is more interesting for you. So there are good courses. Like if you search Andrew Ng on Google, he's the best guy to. I'll just type it here. Yeah. So he is basically a Berkeley professor who teaches machine learning in Coursera, which is a free course. What I will suggest is learn by doing the projects, not just by watching videos, because I have learned myself from doing projects rather than taking a college curriculum or college education or something like that. So do projects and stumble around, and then we all learn that way. Yeah. Anything else? I think we are good then. Thank you for your time in this session, and I hope you will leave this room with some sort of understanding and learning.